Hi guys, welcome back to my channel. I am Rakshita, currently pursuing BE in Venkateshwara College of Engineering, Department of Electronics and Communication. My USN is 1VE22EC090. I am on the topic today is a periodic function in a Fourier series. Introduction to the Fourier series. The Fourier series is a mathematical tool used to present periodic function as a sum of sine and a cos function. It can be developed by Jean-Baptiste Montesquieu Fourier in the early 19th century. The Fourier series is widely used in various fields such as signal processing, physics, and in every engineering field. Definition of a Fourier series. The Fourier series representing a periodic function f of t as an infinite sum of a sine and a cos function. It is defined as a f of t is equals to a naught by summation a n cos n w t plus b n. And this is a representation of a graph of a Fourier series. Periodic function. A periodic function is a function that repeats the values after the certain intervals called the period. Example of periodic function include sine, cosine, square waves, triangular waves, etc. Periodic function has a fundamental period which is the smallest positive values of t, for which f of t plus t is f of t holds of all t's. Periodic function, as I said, periodic function has its own waveforms, characteristics, everything. Some applications of a Fourier series. A Fourier series have various applications in a sign processing, imaging compression, and data analysis. The signal processing. The Fourier series are also used in analyzing and filtering signals in both analog and the digital system. It's both have analyzed in both the waves or both the sides in analog and the digital systems. The image compress techniques such as JPEG utilize Fourier series in representing the compression image data efficiency. The Fourier series is a mathematical method to convert the function into an amplitude versus time dominance. As I said before, it is a mathematical method which converts the function into an amplitude versus a time dominant. It's called to the amplitude versus the frequency determining for a non-periodic function. The Fourier series does not have a non-period function, which the Fourier series does not a periodic function. In the first two diagrams as it's shown in the representing the arrow mark is a Fourier series waveforms. As it below, it's a Fourier transform series waveforms, how it can be formed and how it is there. The Fourier series is widely used in the signal processing for a filtering, noise reduction and the modulation. It is used in the imaging compression algorithms like JPEG to remove high frequency components. The Fourier series has application in physics, engineering and mathematics for solving different equation and boundary values problems. The Fourier series and Percival theorem. The Percival theorem relates the energy of a power of a periodic function. It represents how the power of the function of a periodic function to be coefficient of a Fourier series. Percival states that the sum of the square magnitude of a Fourier series coefficient is equal to the average power of the frequency. This theorem allows us to analyze the energy distributing and the compare different periodic function, which compares the different periodic functions, and it is the energy of a power periodic function. And this is one small example. It's been displayed in this picture. Convergence of a Fourier series. The convergence of a Fourier series refers to how well it's appropriate a periodic function. How well the Fourier series is appropriate to the periodic function. This convergence depends upon the smoothness and the regulating of a periodic function. Some periodic function may require an infinite number of terms in the Fourier series to achieve perfect convergence. And this is the Fourier series to periodic functions. What are this is the formulas regarding this, the Fourier series and the periodic functions. Odd and even function. Odd function may have only a sign component in the Fourier series representation. Even function, it consists of only a sign component in a Fourier series representation. As you can see in this figure, that even function, it only represents a cosine function. In the odd function, it only represents the sign components, as it's shown in the picture. Like example, it's unchanged when the reflects opposite y-axis. It only reflects above the y-axis. The odd function, which represents all the 90 degree change when the rotation of 180 above the origin. It's 180 above the origin. The presence of an odd and even syntax is a periodic function affects the coefficient and the reference components in the Fourier series. Now let's know this Fourier series components are the periodic function. One small example regarding this, a problem. Finding the Fourier series of f of x is equals to x. As it is an odd function, we can know it's an odd or even function after looking after the chart only. There f of x, f of minus x is equals to minus x, where minus f of x. Therefore, f of x is an odd function. It's an odd function regarding minus pi by pi. Hence, a0 is 0 and an is also a 0, and all n is greater than n is less than 0. The required Fourier series B f of x is equals to summation n minus 1 theta bn is equals to bn sin nx, where we should find the bn now, right now, where 2 by pi root 2 by pi n minus pi f of x by sin nx dx is equals to 2 pi 0 by pi s sin nx by dx, where u is x, where u dash is 1, u double dash is 0, where v is equals to sin nx, v1 is equals to minus cos nx by n, v2 is a minus sin nx by n2. Now we should apply Borman's formula. Borman's formula is uv dx is equals to u v1 minus u dash v2 plus u double dash v3, and it's continue. Now let's apply with this formula. Now b by pi minus x cos nx by n plus sin nx by n square whole divided by 0 by pi is equals to 2 pi by 1 minus pi minus 1 n square by n plus 0 is minus 0 plus 0. Now we'll get the bn is equals to 2 minus 1 summation n plus 1 2 minus 1 square n plus 1 by 2 or n. F of x summation. Now let's as we applied before, now we'll take its formula by summation n minus 1 by infinity bn sin nx, where summation n minus 1 infinity 2 minus 1 n plus 1 by n sin n square sin nx. Then 2 is being carried this side, so we'll get 2 summation n minus 1 by infinity minus 1 n plus 1 square plus 2, where sin and nx. Sin is nx. This has been completely proved, or this problem is end by when we proved this. At last, we'll come to the conclusion. A Fourier series is, I said, it's a mathematical method, mathematical expression, everything. The Fourier series is an expansion of a periodic function in the terms of infinite sum of a sine and cos. Without the sine and cos or the even or odd, we cannot find out the periodic functions. The Fourier series makes us of all the orthogonal relationship of a sine and cosine function, how it's related to the sine and a cosine function, how it's been used wherever it will. The computing and the study of a Fourier series is known as a harmonic analysis, and extremely useful as well as a breaking up the arbitrary periodic function into a set of a simple term that can be pulled in the solve individually, and then recombinant to obtain the solution to the origin problem or the approximate to its whatever acumen and the designing of practice. Without this practice, this Fourier series of a periodic function will become a little tough. So make sure to practice more and more with the use of these main terms like sine and cosine, where the sine is being applied and where the cosine is being applied. Thank you guys for all your support and care. Please do like, share, subscribe my channel because it fetch my marks. Please don't forget to like the video. Thank you.